Alright, so this is a presentation come demo of our IoT design project done for EEL 5934 course. The topic of our project is Wireless Industrial Health Monitoring System. This is our team details. We've got one guy from Mechanical, two from ECE, and one from CASE. Our problem statement is to build a scalable prototype of wireless industrial health monitoring system using sensor nodes. And by monitoring this data, we present it on a cloud-based server and we make it available through web and mobile platforms. The prototype looks at addressing the following problems. Number one is constant health monitoring in hostel equipments. Number two is reduction in cabling costs by use of wireless sensors. And number three is overall improvement in workforce management and inventory management, and also improve the design prospects by making this data available to the equipment manufacturer. Moving on to the setup. This is our sensor node. We're using an Arduino Uno board and a Zigbee transmitter for this. The sensors that you can see wired up on the breadboard are the temperature and vibration sensors for the motor. What happens here is that the Arduino board processes the data from these sensors and sends it over through the Zigbee to this Zigbee receiver, which is in turn connected to the Raspberry Pi. This is our gateway node, which is responsible for sending the data to the AWS IoT server. The purpose of using the gateway node is because we are planning to build a scalable system, a prototype of a scalable system. So we can connect tens of these sensor nodes to a single Raspberry Pi, and by just creating new sensor node IDs, we can transmit the entire data to the cloud-based server, which can in turn be made available to the end user. So that's our setup. Now moving on to the demo. This is the command that we're using to run, and as we can see here that the script is running. The data is being published on the display here, but that's not what we need to look at. So if I show you the mobile application, this is device 1 is the temperature sensor, device 2 is the microphone. If we go into the tab of device 1, we can see the temperature. It's 19 degrees Celsius right now. As we all know, it's cold in Gainesville. And the microphone sends up the frequency after the FFT. So this reading we're getting is in forms of frequency. It's right now settled at 152. The fluctuations are quite high because we're in a very quiet environment and it's sensing my voice. But we tried and tested this using a tuning fork with 500 hertz of frequency, which we could successfully sense. Like I was talking about the push notification, we just received a push notification because the temperature has crossed the threshold of 19 degrees. So this threshold is customizable. The end user can pretty much set it to any value that he or she wants, and based on that, we can get a push notification. That's it from my side. Thank you.